The melting point of XeF4 is higher than the melting point of PF3. Explain why the melting points of these two compounds are different. In your answer, you should give the shape of each molecule, explain why each molecule has that shape, and how the shape influences the forces that affect the melting point. So both of these two are simple molecular, so their melting point will be determined by their intermolecular forces, which could be van der Waals, permanent dipole-dipole, or hydrogen bonding, although we can see it's not going to be hydrogen bonding here because there's no hydrogen present. First part of the question though asks us to give the shape of each molecule and how we came up with the shape. So the first one we could do is XeF4. So Xe is in group 8 plus 4 electrons from each fluorine. So that's 12 electrons or 6 pairs. So we can see that there's 4 bonding pairs and 2 lone pairs around the xenon, the central atom, which means that our shape would be XeF4 is square planar. Those lone pairs are trying to get as far away from each other as possible because lone pairs repel more than bonding pairs. So we've got this square planar shape. Then if we look at PF3, P is in group 5, plus 3 electrons from the 3 fluorines is 8 electrons in total, or 4 pairs. And we can see that that's 3 bonding pairs and 1 lone pair around the phosphorus. So PF3 is pyramidal. Three bond pairs and 1 lone pair. So the reason that they take these shapes is that electron pairs repel to get as far apart as possible. Lone pairs repel more than bonding pairs. Now we know that F is more electronegative than everything because it's the most electronegative element in the periodic table. So it's more electronegative than P or Xe. So both molecules have polar bonds. So we might think that both molecules have permanent dipole-dipole forces. But what we need to remember is that XeF4 is symmetrical. So the dipoles cancel. And van der Waals forces are the only force between molecules. And then we're sort of thinking, well, if PF3 has permanent dipole-dipole and XeF4 has van der Waals, why is it that XeF4 has a higher melting point? I think the question was asking us, yeah. But we need to remember that XeF4 is a much larger molecule than PF3. If we look at the number of electrons, so the van der Waals forces between XeF4 molecules are stronger than the permanent dipole forces between PF3 molecules.